Hello, this is Mr. Doro, and today we're going to be talking about mole conversions. I want you to be able to convert between moles, grams, and representative particles by the end of this little tutorial. And today is a special guest with me. I have my cousin, who is from Romania. His name is Miguel Anrano Cadarini Odala Floriano Edona Smoichenbagel. And Miguel, thank you for being here, and welcome to this tutorial. Thank you very much. It is very nice to be here with you today. Do you use moles in your country? Moles are used across all of the countries, and that is why they are SI units for the amount of substance. Okay, thanks. Well, one of the first things that we have to know about are representative particles. These are the smallest units that you can count for the substance. And there are three types of representative particles. One of them is atoms, and that's for single elements. I've given you an example of a single element that you would get off the periodic table, like aluminum. Another one is molecules, and H2O is a compound that is composed of nonmetals, and so the smallest thing that we could count on the H2Os is one molecule of this. That's one set of H2O. The other one we don't use all the time, but it is out there. It's formula units. That's ionic compounds. That means a metal and a nonmetal together, and like NaCl. But normally I will just call this molecules each time, but formula units is the correct name for it. Do you agree with that, Miguel? Yes, I do. Okay. As far as conversions go, there's really only two conversions that you need to know to do mole conversions. And here they are. They are 1 mole is 6.02 times 10 to the 23rd particles. Now that particles could mean that is atoms or molecules or formula units. You got to be careful when you represent. I'd like you to write form units. Okay, just don't abbreviate that too much. And then 1 mole is the molar mass in grams. And that molar mass, you should write down that this is from the periodic table. You calculate that from the periodic table. We already had a video tutorial for that. Do you know how to calculate molar mass, Miguel? Yes, I do, very much. Okay, good, thanks. This is a mole roadmap. You'll be given a copy of this to help you get started on doing the action lines, but just don't rely on it too much, because when we have quizzes or tests, you won't be able to use it. You can see that in here we have 3 different sections. Actually, there's one section that we will not be using. That section is this volume section. We won't be using that for right now. Later on we might be though. But the 3 sections are these. You have the representative particles right up here. You have the mole area, and that's why I have a picture of the mole, and you have the mass area. Mass is in grams, that's why I have the grams there. Representative particles are those 3 things that we talked about: atoms, molecules, or formula units. And moles are just, well, they're moles each time. So if you're given atoms, then this is what you're going to do. You're going to start out your action line with what you're given, and let's say you're given atoms and you're asked to find moles right here in the center. So you start out with atoms in your action line, and then this tells you really what you put on there. This is that conversion factor. 1 mole is 6.02 times 10 to the 23rd particles, or atoms, or molecules, or formula units, whatever we're talking about. That gets you to moles. You got to follow the arrow. Don't go against the traffic, because you'll end up with a head-on collision here. But if you're given moles and you're asked to find representative particles, then you start your action line with moles and you go through this section right here. You follow the arrow, 6.02 times 10 to the 23rd particles on top, which is going to be atoms, molecules, or formula units. We never write particles. And 1 mole on the bottom. Same thing with this down here on the bottom. If you're given mass and asked to find moles, then you're going to put in your action line on the bottom the molar mass, which comes from the periodic table. And you'll plug that in, and you'll just go in this direction right here to get to moles. And then if you had to keep on going to particles, representative particles, you would go in this direction. It'd be a 2-step process. We're going to practice some now. Is that okay, Miguel? Yes, it is. Good. Remember that these practice problems are your examples, so you really should have them down in your notes. I'll be checking that you do. This question gives us the number of molecules, and it asks us to find the number of moles. Now, we can either look at our mole roadmap or just use our 2 conversions that we've already written down. We start out with what we're given, 3.35 times 10 to the 24th. That makes a difference. You have to include it. I know you have to write out this whole molecules, and I want you to write the H2O. That's a lot of writing, but trust me, it can be done, and there's a reason why I want you to do it. Think about this without even looking at the map. What we're going to do is take this unit and copy down. That's what we do each time. So I'm going to put molecules of H2O. down here. And above, I can go directly from representative particles or molecules to moles of H2O. That's an O down there. Okay, now what are the numbers? Look at your conversion factor. Anytime you're switching these, a 1 is going to go in the moles. The number of molecules is the number of representative particles. For every 1 mole, it's 6.02 times 10 to the 23rd. And then molecules cancel out. You're left with moles, and now you just calculate it. Plug that in your calculator, see if you get what I get. As far as sig figs go on this, you have 3 sig figs in this number, 3 here. This is an exact quantity, so it doesn't limit our number of sig figs. What'd you get for that, Miguel? I got 5 in 3 sig figs. Yes, 3 sig figs. I got 5.56, and that is the number, so we don't need scientific notation, moles of H2O. That is perfect, Miguel, and I like him to put a box around it right there. Here's another problem. You're given in this one the number of moles, and you're asked to find grams. We can do that because we know a relationship between grams and moles. The molar mass is really grams per mole. And so we start out with what we're given. I'm going to plug them in right now. In fact, you should stop it, and you should plug it in while I'm stopping it too. Go ahead. There's my beginning number, 9.9561 moles of CO2. So I'm going to copy down the moles of CO2 down here. And I can change that to grams of CO2 because that's the molar mass from the periodic table. And so if we look at our conversion charts on our notes, go ahead, you wrote them down, look back there. That's right, you got 1 mole, and this one comes from the periodic table. You do 12.01, that's the carbon, plus 2 times 16.00, that is the oxygen, and you should end up with 44.01. That's the biggest mistake that students make. They set this up many times, but they don't get that molar mass correct. So make sure you're calculating that correctly. And now, what ends up happening is the moles of CO2 cancel out. I'm left with grams of CO2, which is exactly what I wanted. That's what I was asked to find up here. And so my answer will be in grams of CO2. I want you to plug it in and see how many sig figs. It really doesn't help you if you just copy down my answer. You might not know how to do the end ones. So you plug it in, stop it right now, see what answer you get. Here's the answer I got on my calculator. I was going to have Miguel do it, but he had to use the restroom. And so 4338.167961. This sig figs, I have 5 sig figs there and 4 there. This is an exact quantity. So I need 4 sig figs. That's these 4. And that one tells me I rounded up. So my answer in scientific notation is 4.382 times 10 to the second grams of CO2. This one is a little bit more difficult, and so we're going to go ahead and start plugging it in with things because we don't have anything that relates grams directly to molecules, so we have to go to an intermediate in between. I'm going to start out with 515.32 grams of CH4, and then I know that I have to copy down grams of CH4 on the bottom. And so what can I change grams to? Not to molecules. I can go directly to moles though by using the molar mass on the periodic table. Molar mass means the mass for 1 mole. So for every 1 mole, I calculate this out. Carbon on the periodic table is 12.01. Hydrogen is 1.01, but there are 4 of them, so we have to multiply that by 4. And I get 16.05 grams. And you can calculate that separately if need be. Grams of CH4 then cancel out, and I continue on. I'm going to copy down moles of CH4. And I can change moles to representative particles, which in this case is molecules of CH4. And for every 1 mole, there are 6.02 times 10 to the 23rd molecules. There's only 2 conversion factors that you need to know, and you need to put them together. Then I multiply everything on top. I divide by everything on bottom. Sig figs, this has 5 sig figs. This has 4. This has 3. That does count as only 3. These are infinite numbers of sig figs, so they don't really matter in the limitations. So calculate that out. This is the big old long answer I got, and then we said that we needed 3 sig figs. Don't forget to include this part right here. And so this is 1.93 times 10 to the 25th molecules of CH4, and then I like a box around them to show that's your answer. So here are 3 of them for you to do. You can show the action lines. You need to show the action lines and report your answer in the correct number of sig figs and scientific notation if necessary. These 3 action lines are very similar to ones that you've done on your examples. So look at your examples and be able to do them. Hold on just a second and I will show you the answers that you should get on here. And here are the answers that you should get in the correct number of sig figs and in scientific notation. Now, if you're not getting these answers, then I would go back and look at your molar masses that you calculated for each of these on the periodic table. Usually that's where students go wrong. Also, notice this, I gave you a formula units here, and normally I don't give formula units. I might just call that molecules from here on out, but that's the correct term for it. And oh, here's Miguel, he's back. So Miguel, thank you for joining us today, and I'm so glad that you were here. It was my pleasure. Thank you so much for helping. I hope your students work very hard and do well on this. Thank you, Miguel. I hope so too. And you have a great day. Bye-bye.